Okay, so welcome to this video when we are going to discuss the naive Gaussian elimination, one of the numerical methods in solving system of equations. Okay, so we have naive Gaussian elimination. So first we have the definition. So it is considered as the direct method for solving. So for solving system of linear equations, in the form of a times x is equals to b. Now, wherein our a is an n by n coefficient matrix and b is the right hand side vector. So meaning, so our a are the coefficients, our x is the number of variables or the unknowns, and b are the constants. No, so for example, if we have um, two equations, for example, x plus y is equals to 7, and 2x plus y is equal to 8. So if we're going to have this one on a a times x, so we'll be creating a matrix now for the coefficient. For this one, the first equation, the matrix is 1, no, that is for the first coefficient of x, then 1 for y, then you have 2 and 1. No? Then we will have here the unknowns for the variable, so this will be x, y, and we have the constant which is 7 and 8. So this is what we mean as a by x, now which is equal to b. So the b is the right hand side vector. The a are the coefficients of the each of the unknowns of the equation. Okay, so let's proceed now with the two main phases of our naive Gaussian elimination. The first one will be forward elimination. So that is to transforming the augmented matrix into an upper triangular form. Okay, so going back to this one, so if we have now the augmented matrix, so the our previous example, this one, this is also 1, then we have 2, 1, okay, then we have here the variables x, y, and this is equal to 7, okay, 7 and 8. Let's check first if that's correct. Okay, correct. So we're going to have this one as an augmented matrix, okay, okay, so we will just have this one as, okay, so we just have this one as 1, 2, 1, 1. So we will drop the x and y, no? And we'll just put here a sort of a, okay, just erase this first, okay. Sort of a bar, no? Okay, in which we'll put here the constant. So we now have the geometric matrix. Now this one, this a, so this is our a, the coefficients. So we need to make this one into a upper triangular matrix. So to make that one upper triangular matrix, we must find a way that this 2 will become 0, no? So if we're going to have this one as 0, so what we're going to do? So we need to find a way that the first one here, no? If added or subtracted to this part here, our 2 will be 0. So what we are going to do is our, let's say that for row 2, so 2 times row 1, then minus row 2. So meaning, our row 1 will be multiplied by 2, so this will be 2, then deducted by R2, the row 2 here. So that will be 2 minus 2. So we just copy our R1, our row 1 first. So this will be 0. Then the next one, 2 minus 1, no? Because this will become 2 because it's multiplied by 2. This will be equal to 1, no? Then we have 2 times 7. So this will be 14. Then 14 minus 8. So that will be 6. So we have 7, 6. Okay. So now we will have now our, this now will become an upper triangular matrix. No? And because from this one, we know that this side is for y. So we could say that y is equal to 6. Now what we are now doing now is the back substitution. So solving the given from bottom to top. So after the upper triangular matrix. So our x equals to 0. So our y here is equals to 6. Then substitute this one. So we have for this formula here, or for this equation here. So x plus y is equals to 7. So we have x plus 6 because our y is equals to 6. So x is equals to 7 minus 6. So our x is equals to 1. So meaning from this equation, no, from this equation, the value of our x and y are 1 and 6 respectively. Okay? So that is the process of the naive Gaussian elimination. Okay, so to understand this further, I believe these two equations to understand is very easy. So it could be solved using substitution or elimination. No, so the very basic ways of solving the linear equations. So we will be having some examples. So we have this one here. So solve for x, y, and z for these three equations. So we have x plus 2 is equals to 7, x 2x plus y plus z is equals to 7, and x plus y plus z is equals to 6. Okay, let's start. Okay, so we have our solution. Okay, solution. So we have siguro color green, no? Okay, so first we need to create the matrix, no, the A times B matrix, no, that form. So first we must get the coefficients, no? So we have for this one, the coefficients for x is 1. There's no y, so that is 0. For z is 2. The second equation, so that is 2. This is 1, and this is 1. Then for the third equation, that is 1. So y is also 1, and z is also 1. Okay. So we have x, y, and z. And you have here 7, 7, and 6. Okay. Now we will do the augmented matrix, no, of A slash B. So you have 1, 2, 1, 0, 1, 1, 2, 1, 1. Then this will be 7, 7, and 6. Okay. So for to make this one very easy, so we just, this is the first time of you to use this this elimination. No, so we just label first our rows. This will be our row 1, row 2, and row 3. So the first thing to do is to find a way that the leading elements, no, the 2 and 1 here will be 0. No, so what we are going to do first is to, for row 2, so we need to multiply row 1 by 2 and deduct row 2. Okay. Okay. So let's have that one. Okay. Then for row 3, now just also continue row 3. So row 3 is just, we have done as row 3 minus row 1. Okay. So you can have also this one other way around, no? So for this one also, if you want to have row 2 first, no? So we have R2 minus 2 R1. So you can have that one. Okay, so let's have here our new augmented matrix. No, so we have our row 1, 1, 0, 2. Okay, so this will be 7. Okay, so we have for row 2, so row 2 now will be equal to r row 2 minus 2r1. So that will be 2. So this will be 2 minus 2. So this will be equal to 0. Then 1 minus 0, no, because 0 is our r1 here. So this will be equal to 1. Then we have 1 minus 2 times 4. So 1 minus 4. So this will be equal to negative 3. And we have 7 minus 14. So 7 minus 14 will be equal to negative 7. Okay. So negative. For row 3, so we have automatic, no? 1 minus 1 is 0. Okay. Then 1 minus 0 is 1. Then 1 minus 2 is negative 2. And 6 minus 7 is negative 1. Okay, so let's try to check first. No, this will be 0, 1. So that will be 1 minus 2. So, this is not negative 2, but negative 1. Okay, so the next part is we need to find a way to have this one as 0. So what we are going to do is to subtract. No? So for R3, so we have R3 minus R2. So if that's the case, we just copy the first two rows. 7. So this will be 7. Then you have 0, 1, negative 3. And this will be 0. No? So 0 minus 0 is just 0. Then 1 minus 1 is 0. Then 1 minus 1 plus 1 minus negative 3. So that will be positive 2. Okay, so just copy this one, negative 7. So we have also 1 negative 1 minus negative 7. So that will be 6. No, 6. Okay. Okay, so this is now here is we have made a triangular upper triangular matrix for this one, and for the third row we could now solve for our y z, no, for back substitution. So 2z is equals to 6, so our z is equals to 6 over 2, which is also equal to 3, no. Then we will be going to use row 3, no, row 2 for this one. So we have y minus 3z is equals to negative 7. Okay, so we have, so y is equals to negative 3 times 3 is equals to negative 7. So we have y minus 9 is equals to negative 7. So y is equals to negative 7 plus 9. So our y is equals to 2. And using equation 1, which is x plus 2z equals to 7. So we have x plus 2 times our z is 3 is equal to 7. So we have x plus 6 is equals to 7. So x is equals to 7 minus 6. So our x is equals to 1. So in general, no, so our x, y, okay, x, y, and z is equal to 1, 2, and 3 respectively. So this is now our solution of the three equations, no, using naive Gaussian elimination.